Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python Part 1. This is the sixth class of the series, Set, Array and Dictionary Data Types. Objectives of the class today is to learn about the set data type and some operations with sets in Python. We will also learn about the array data type and some operations with arrays in Python. We will also learn about the dictionary data type and some operations with dictionaries in Python. We will learn the differences between arrays, sets, lists, dictionaries, and tuples. The motivation. Array is one of the most used data types in Python, so it is good to have a thorough knowledge of it. You will discover that after we advance beyond this foundational level of Python programming, when you start applying Python to other areas such as artificial intelligence, data science, the use of arrays become very important. Dictionary is also one of the most important data types in Python, especially for collection of variable data. So it is good for the aspiring Python programmer to have a thorough understanding of dictionaries and the available operations of them. Set is also another important data type in Python to be studied. Now, by the time we finish this class, we would have had a knowledge of several data types in Python. So it is good to understand the similarities, the differences between them, so that as a Python programmer you can know which one to use for which particular situation or for which particular problem you want to solve. So at the end of the class, participants should be able to describe the array data type in Python, describe various ways of creating arrays in Python, and describe some operations on them. Write a Python program to create arrays and perform various operations on them. Describe the dictionary data type in Python and various ways of creating dictionaries and various operations on them. Write a Python program to create dictionaries and perform various operations on them. Describe the set data type in Python and various operations on them. Write a Python program to create sets and perform various operations on them. Finally, you should be able to differentiate between sets, arrays, dictionaries, lists, and tuples. Content. Introduction to the array data type. Introduction to creating arrays. Python array versus NumPy array, arrays versus lists, set data type, creating sets, introduction to the dictionary data type, creating a dictionary, changing, adding and removing elements in a dictionary, accessing elements in a dictionary using get, and we see a Venn diagram for list, set, tuple, and dictionary. So we begin with arrays. An array is a data structure that holds a collection of items, just like a list. Characteristics of arrays are much like lists. Array items are enclosed in square brackets, just like a list. Array items are ordered. That is, the items appear in a specific order, just like a list. So we also use an indexing system to access any item. Array items are mutable, or arrays are mutable, just like a list, which means you can add or remove items from an array after it has been created. Array elements also need not be unique. Item duplication is possible, just like a list. So we can have three names that are the same: Jonathan, Jonathan, Jonathan. However, whether array elements can be of different data types, like lists, depend on the kind of array you created, which means that there are different kinds of arrays that are possible in a Python program, and we'll see them as we progress. To use arrays in Python, you need to import either an array module. Later on we'll learn about modules, what they mean. Or you will import a NumPy package. So let's go straight to program examples. We are going to create arrays in two ways, either using Python array or using NumPy array. Let's start with Python array, the one that comes with a Python installation. After you install your Python, an array class is automatically installed with Python, and you can use that directly to create an array. So we call this program Python array 0.py. To demonstrate Python arrays, which is the one that comes directly with your Python installation, take note that Python arrays do not support different data types. To use an array, you must import either an array module or a NumPy package. So since we are using Python array here, for this one, what we are going to do is import the array module. This one is Python array. So we say import array as ARR. This is what we call an alias for the package array. Later we will learn what this means and how to do this and build our own packages. So main program begins. We start by creating an array. Call it array1. Now you have to use the module you imported to create the array. So we say arr.array. Take note that this arr is just an alias. It could have been your name you put there. Thomas.array. So we have arr.array, and then we indicate which kind of data type we are creating this array for. Like we said, Python arrays do not support different data types, so you must indicate which data type you are creating an array for. I stands for integer data type, so every element in the array you will create must be integer. So we have an array that consists of 1, 2, 3, 4, 5 items. We've created the array of integer elements. So if you print the array, it's going to show the array on the screen. We'll run the program and see how it works. So we can also print the type. Remember, we've learned about this before when we were learning about data types in Python, and we see the kind of type that it will print out later. So the second method to create arrays in Python is to use NumPy arrays. So we'll call this program NumPy array 0.py to demonstrate NumPy arrays in Python. So we import NumPy as NP. Remember, we have already installed NumPy in some of the first classes. In fact, you need to install NumPy. Otherwise, you cannot use NumPy because it doesn't come directly with your Python installation. It is more powerful than the array that comes directly with your Python installation. So before you can use NumPy, it must be installed. And if you don't know how to do that, I suggest you go and watch the second video of the series, which is Introduction to Programming and Software, and you'll learn how to do that. But in case you can't go back, I can show an example while we run the program. Now let's progress from here. Main program begins here. NumPy arrays support different data types just like lists. So let's create an array. We call it array2 equal to np. You still use the alias dot array, and we don't need to specify whether the data type is an integer or float or string or whatever. No, we don't need to do that with NumPy arrays. We just go ahead to define the array elements. You can see the elements. First one is a string called numbers. The rest of them are integers. You can mix them up like this. You can put a boolean, you can put a float, so on and so forth. So we can print array2 and also print the type of the array. Okay. So let's go straight to see how these programs are running and the kind of outputs we get from the program. So in the last class, we already learned how to open our program directory in Visual Studio Code. In case you don't know how to do what you are seeing here, go and watch the previous video before this one. So let's start with Python array. This is the program for Python array. Now pull this back. I have already explained the code, so I will just run it here and see what the print outputs are producing. And we can modify this program. Since this is a single line, I'll use this comment and look at the output of the print. So the output you see to the right is what this print statement has produced for us. Just printed the array exactly the way it is. Array I 3, 6, 9, 12, 24. If we comment this out, what type of array? The class is array.array, which means this is Python array. Okay, so we'll close this now and open the NumPy array program. This is the second program. Again, we'll comment this out. Or let's open ARrayPF first before commenting, so we can see the changes directly. Right. Although this ARrayPF produces a warning, but you can ignore the warning. What we just want to see is the output that is on this side. That is the array that is printed out. Now if we comment out the next line, see the class is numpy.ndArray. The previous one was array.array. That is Python array. This one is NumPy array. Alright, so in case you forgot how to install NumPy, let's see whether we can go through it again. We can show a terminal, wait for the terminal to load. Right, and you can say, if you don't have NumPy, you can say pipe install NumPy. I have already installed it, so it's not supposed to install it again. So these are the outputs that we just demonstrated for the two programs that we ran. Now let's look at arrays versus lists. Let's try to compare and contrast. It is easy for somebody to get confused because they are very similar. So we'll put arrays on one side and we'll put lists on the other side. First, arrays need to be declared. You have to declare them in your program. This requires a specific function from either the array module, which is array.array, or from the NumPy package, which is numpy.array or ndarray. Lists on the other side do not need to be declared. The moment you start your Python program, you don't need to import anything. You just create a list and it works, because they are built into Python directly. That's why lists are more often used than arrays. A second difference is arrays can store data very compactly, and they are more efficient for storing large amounts of data. Lists are less efficient than array for storing large amounts of data. That doesn't mean that lists are less efficient. Arrays are also designed to support numerical operations. For example, in matrix and vector algebra. For example, you can divide each element of an array by the same number with just one line of code. We see an example of that. If you try that using a list, you will get errors because arrays were designed mathematically. Lists were not designed like that. Lists cannot directly handle mathematical operations without writing a lot of code. In fact, if you want to do math operations, matrix operations, use arrays instead of lists. Topics such as data analytics, data science, etc., they rely heavily on mostly NumPy arrays. So if you look at the NumPy user guide in the bibliography, you will understand that better. Now we'll see another example that demonstrates arrays versus lists. We call this NumPy array versus list.py. As usual, we import NumPy and give it an alias. Popular alias is np. Main program begins here. So we say array1 equal to np.array 1369. This is a NumPy array of integers. Array2 is equal to np.array, which contains floating point numbers together with integers. And let's also create a list along with them. A simple list of integers. Now let's try to do direct division of an array. If we create a variable and say division equal to array1 divided by 3, it's like a matrix operation where you just use 3 to divide every element. So every element is divided by 3. And you know what that's going to be. The first element will now be 1 over 3. The second element will be 3 over 3. That is 1. 6 over 3. That is 2. So on and so forth. Directly. So if we print division, we will see what we'll get on the screen. It will not produce an error. You can do that with arrays. We can also do something like a direct multiplication. Array1 star 2, in which every element in array1 is multiplied by 2. So we are going to get 2, 6, 12, 18, 24, 48, something like that. We can do direct addition. Addition of array1 with array2 directly, just like the way you add matrices of vectors. In which case, every element of array1 is added to the element of array2 in corresponding positions. So we have 1.5, 4.3, 11, so on and so forth. Now if you try this same direct mathematics operations with lists, you will get errors. For instance, if you say print list division is equal to list 1 over 3, it will generate an error because lists are not designed for mathematical operations. So if you want to do the mathematical operations on a list, you have to do that indirectly by walking through the elements of the list one by one. So let's say we create an empty list and call it div list, and we'll put it in a for loop. For list item in list 1, div list dot append list item over 3. So we are doing the division one by one in a loop, and that is the only way we can do that, which is an inefficient way of doing the mathematical operation. If you run the program, this is the output that you are going to get, but we are going to go straight to run the program. So let's go back to Visual Studio Code. NumPy array versus list, that's the program. We start by doing our docstring comment. Since we have more lines of code to comment here. Good. So the first output you are seeing here is the division, the product of a division, which is this one. division array 1 over 3. So 1 divided by 3 gives us 0.33333. There is a way to set the precision. We can see that some other time. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. 12 divided by 3 is 4. And 24 divided by 3 is 8. That's where it's coming from. So let's see other outputs. The second one is we multiplied everything in array 1 by 2. And what do we get? 1 times 2, 2. 3 times 2, 6. 6 times 2, 12. 9 times 2, 18. 12 times 2, 24. 24 times 2, 48. Let's see the addition of two arrays. So add array. 1 plus 0.5 gives us 1.5. 3 plus 1.3 gives us 4.3. 6 plus 5 is 11, so on and so forth until you get to 44. Okay, now we are going to try the mathematics operation directly on the list. So I'm going to uncomment this print. Print list division, list over 3. So we see the red box shows here. And type error shows here, unsupported operand. So we can't do that directly using a list, the way we did it using an array. So how do we do that? Indirectly, we put it in a for loop like I explained before in the code. So if we put this here, what do we get? So the output we got here is list division, which actually use the for loop to do the division and append the results one by one to div list, which is a tedious way of doing the mathematical operation. So we have seen the differences between arrays and lists. So we'll talk about set data types. Actually, what we have learned about array is just in the surface. In fact, NumPy array is a course on its own, a full course on its own. So we stop the array topic with what we have done so far. Now let's talk about the set data type. What is a set in Python? A set is a data structure that holds a collection of items just like a list. However, unlike a list or dictionary, a set is unordered, not ordered, and duplicates are not allowed in a set. So if you have learned anything about set theory in mathematics, you discover that a set in Python is actually modeled after sets in set theory. So characteristics of sets. Set items are enclosed in curly braces like this. Set items are not ordered, meaning that an item can appear in any position in the set. However, set elements must be unique, so item duplication is ignored, and we are going to see that in an example. Set elements can be of different data types also. Set elements are immutable, just like tuples. Elements cannot be changed once created. See an example. Python set 0.py. One way to create sets is to create the set directly. So we create a set of distances. Call it distances 1, 10.6, 11, 8, 10.6 again, 2, 7. Recall that we said that set elements must be unique. So in this creation we have 10.6 appearing twice. You will discover that only one of the 10.6 is going to be retained. The set will automatically discard the second 10.6 and even possibly rearrange the list of items because the position does not matter. It's unordered. That's what a set is. And you can discover that there are different data types. This is a string, 3 integers and 1 floating point. So when we print distances, you will discover that the second 10.6 has been ignored, as we will see in the programming example. We can also print the type, and we discover that the type is set. Another way to create sets is start with an empty set. So we say distances equal to set, nothing in the parentheses. If you print distances 2, you'll get an empty set. So you can also create a set by using a list. We created a list called James, and then we'll put some data in the list, different data types. We can now say distances 3 equal to set James, and the set is created, and we can print it. If you run this program, this is what you get in the output. Python set 0. So do a docstring comment from the second print. So we can see the output. We created a set that contains two 10.6 inside it. But when we printed distances, what do we have? Only one 10.6. And you can observe that the set has been rearranged. 7 is now in front, 8 follows, 10.6 follows, 11 follows. The numbers in ascending order before 2. So this shows that set is unordered. The position where the items are doesn't matter. And it also shows that set elements must be unique. If there are multiple elements, the rest will be ignored. So if we print the type, what do we have? The class is set. So another way of creating sets is to just create an empty set. And when you print distances 2, what do you have? Empty set. Another way of creating sets is we first of all create a list. Then we put the list inside a set creation, or we use the list to create a set. We print distances 3. And what do we have? 2, 4.4, 5, 1, 3 in ascending order of arrangement again. That's for creating sets. And that's that for sets. Now let's look at the dictionary data type, which is a very important data type in Python. A dictionary is a data structure that holds a collection of key value pairs. Characteristics of dictionaries are much like lists. Dictionary items are enclosed in square braces with a key value pair. So we have a key like key 1, which must have an associated value. You can have as many keys as you want. Key 2, value 2, key 3, value 3, up to key 1 million, value 1 million, as much as you want. It's up to you. So a key value pair is a set of values associated with each other. For instance, if I want to capture student data, there are some keys we can use. For instance, surname is a key, first name is a key, age is a key, height is a key. The values associated with them can be anything. Any surname, any first name, any age, any height, any eye color, whatever. If you provide a key, Python can return the value associated with that key. Every key is connected to its value by a colon, as you can see there. And individual key value pairs are separated by commas. You can store as many key value pairs as you want in a dictionary. A given key can appear in a dictionary only once. For instance, a key of surname cannot appear twice because that will cause confusion. It can only appear once. Dictionaries are dynamic structures. meaning that you can add new key value pairs to a dictionary at any time. Let's see an example. Python dictionary 0.py. The simplest dictionary has a single key value pair. So we say dict 0 equal to color green. Here color is the key and green is the value. If we expand this dictionary, you can only have one color, but green is a variable that could be anything: red, blue, yellow, so on and so forth. Let's take another example which is not so simple. So the key here is fname, which is supposed to stand for surname. It could have been S name, whatever you want to call it. Abuchi. L name Obi. Age 19. Eye color brown. So if you print dict 0 color, what's going to come out? It will give you the value green. If you print your name is person 0 fname, you give it the key. Person 0 lname, you give it the key. And you are person 0 age, you give it the key. You will always give it the key, and Python will return the value. So the statement is going to be your name is Abuchi Obi and you are 19 years old. You can also add new key value pairs if you want. For instance, person 0, you forgot to include an email earlier on, you can just create a new key. Email equal to, you equate it to the value. Person 0 phone equal to, you equate it to a particular phone number. Person 0 height equal to, you equate it to another value. And when you print it, it is going to show the full list of dictionary values, key value pairs that have been added to the previous one you created. So the keys will be fname, lname, age, eye color, email, phone, height. Now we can also start to create a dictionary by using an empty dictionary. So we say person 1 equal to just empty and start filling it up. Person 1 fname equal to assign a value. Person 1 lname equal to assign a value. Person 1 height equal to assign a value, and you print person 1. So what this tells us is that if you actually want to create a real software that collects data from people using Python, for instance, before you registered for your Yahoo Mail, you had to enter some data. Such kind of data are likely to be collected by using a dictionary. So you have a lot of dictionaries that will be kept in a list, meaning that when you create a dictionary, you don't need to provide all the values immediately. For instance, we have an empty dictionary. You can provide the values in a loop that runs. As the users are entering their data, you are creating a new dictionary and adding the value, just like that, and you make a list out of it. So if you run this program, this is what you get. We are now going to go to Visual Studio Code and try to run the program and see what we get. Python dictionary 0. So the first output we got from the first print is we gave the key and say print dict 0 color. We gave the key, and what do we get? The value. If we change the value to red and we give it the key again, it's going to print red. Okay, so let's make a statement out of it. Print your name is Abuchi and you are 19 years old. That is the second print, which is this one from the second dictionary we created. So let's add some more items to the dictionary and finally print again. So you see, when we printed the dictionary, after this addition of more key value pairs, we now have F name Abuchi, L name Obi, age 19, eye color brown, email, phone, and height. The dictionary has expanded. So let's see what happens when we start with an empty dictionary and we print. Call it person 1. So what you are seeing here is person 1. F name Musa, L name Isa, height 1.5. That's our first dose of creating dictionaries. Now let's look at adding and removing elements in a dictionary in more details. We'll call this Python dictionary 1.py. So we'll go back to our old dict0, color green. Print it to get color green. Now suppose we want to change the item green. We want to change the value green to red. All we need to do is just call the key and assign a new value. We say color equal to red, then we'll print it again. This time it's going to print red. Now let's do something a little bit more elaborate. We'll create a dictionary and we'll call it robot0. A key is X position, the value is 0. Another key is Y position, value is 25. Another key is speed, the value is medium. We can print a statement and say original X position, call the key robot0 X position. It's going to print 0. That's the original position. Now let's do something using an if statement. If robot0 speed, we call the key speed, equal to slow, we are testing if the speed is slow. If the value of the key speed equal to slow, then create a variable called s_increment and set it to 1. Otherwise, if the speed key of robot0 has a value of medium, the variable x_increment should be set to 2. Otherwise, x_increment should be set to 3. Now let's do some update. We call the key X position will now assume a new value. It's going to be the previous X position plus the x_increment variable that we are going to get from the if statement, depending on how it was executed. Now let's print the new X position just by calling the key again. We'll see that when we run the program. We can also remove key value pairs from a dictionary. Just like a dictionary can grow, it can also shrink. So let's say dict0 point equal to 5. The reason why I added a new key is because I want to demonstrate this removing of key value pairs from dictionary 0. Okay, and it has only one key. So if we remove that only one key, which is color, it's going to be empty. So let's add another key and then remove one key so that we'll have something to show, just for the purpose of demonstration. So we print dictionary 0 and we discover that it now has 2 keys, color and point. Now let's try to delete the color key. We just say del dict 0, call the key color, print it again, and you discover that it has only one key, and that will be points. If you run the program, this is how it's going to look like. So we'll go straight to run the program. Alright, so initially the dictionary has only one key value pair. Then we added, the first thing we did was try to change the value of the color from green to red, and when we print it again, the color is now red. And then we created another dictionary and we call it robot 0, and we print the original position, X position, as 0. So we created an if statement to create a variable called S increment, whose value will depend on whether the key speed has the value of slow or medium or something else. Of course, we know that what we kept there was medium, so it is actually medium that is going to be executed. X increment will be 2. Let's put the doc string here. See? So when we print the new X position, the value is 2, because the original 0 was added to 2, which is this one. We have updated the X position of the dictionary robot 0. Now let's look at removing key value pairs. First thing we did was add another key to dictionary 0, and the key is called points. The value is 5. And we print out the dictionary, and what do we get? An expanded dictionary that now contains key color and key points. We now want to remove key color. We say delete color, and then we print out the dictionary again, and what do we have? It has shrunk. We now have only points key, and the value is 5. Accessing elements in a dictionary using something called get, a function called get. If you have a dictionary of similar objects, you can break it into several lines when you write the code for the purpose of readability and clarity. So we create a dictionary that is called favorite languages. Jen, key Jen, her favorite language is Python. Sarah, C, Edward, Ruby, Phil, Python, and we'll close it. Now all of these things could have been written in a straight line, doesn't make any difference, but if you write it like this vertically, it makes it easy to understand when somebody is reading your program and when you are reading it in future. So that's one thing. We can print favorite languages and to print the key value pairs. So if we create a variable and say language equal to favorite languages Sarah, we call the key Sarah, and we say dot title, it's going to print C in capital letters because of the title. We say print Sarah's favorite language is language. Sarah's favorite language is C, C in caps. Now suppose we try to access a value whose key does not exist. We get an error. If we look at the favorite languages list previously, David was not included among the keys. So if I write a statement and say print favorite languages, we call a key that does not exist in the dictionary, we get a traceback error. How can we handle something like this? we use the get method to set a default value that will be returned in case a person requests for a key that does not exist. This prevents our program from crashing. So the best way to do it is we can say language equal to favorite languages dot get gen no point value assigned. What is happening here is if you use get and then you put a key that you want to call, for instance gen, you will put a default answer here that will be executed in case gen is not found in the dictionary. So if gen is not found in the dictionary, the message that will be returned will be no point value is assigned, or whatever message you want to put here is just a string. You could as well say key gen is not in the dictionary. It's as simple as that, to avoid an error that will crash your program. So if we say print gen's favorite language is language, if gen is there, it's going to print it. But if gen is not there, it will rather say no point value assigned. Now let's say language equal to favorite languages dot get Jacob. We know that Jacob is not in the list, so you can just send a message and say no language is assigned. If you print Jacob's favorite language is language, what is going to print out is no language assigned. If you run the program, this is what we get. So let's go straight and run the program and see how it works. This one is dictionary 2. Docstring comment. So even though we wrote our dictionary like this vertically, when you print it out, it still print it like this. We'll make a statement. Sierra's favorite language is C. Because it is dot title here, the C is capital. Now we will demonstrate something that happened if we call it directly without using the get function. So let's do this. I'm going to uncomment this code that says print favorite languages David, even though David is not in the list. See, David is not in this list. So if you call it directly the way we have been calling it and say just print favorite languages, you call a key that does not exist, what do you have? Key error David, meaning that David does not exist among the keys. Now this is enough to stop your program. It's not running anymore. It has crashed. So let's comment this out again and use the get. Use the get method which I described earlier. So if I put this here and then I say language equal to favorite languages dot get gen. Gen's favorite language is Python because gen is listed. Now where this becomes useful is when you are trying to call a key that is not listed. We get Jacob. Jacob's favorite language is no language assigned. See, it didn't generate an error. It just carefully avoided the error and then your program keeps running. Okay, so that's what we did with the get. So we have been learning about a lot of data types, lists, sets, tuples, dictionaries, arrays, so on and so forth. And it can be confusing for the beginning student to comprehend the differences and similarities between them and how to differentiate. One of the ways to make it easy is to look at a Venn diagram that shows you the relationship at a glance. So we start with a list. A list is mutable. That's one of the characteristics associated with list, meaning that you can change an item. If we look at a dictionary, it has a relationship with lists in the sense that the items of a dictionary are also mutable. You can add, remove, change. What about a tuple? Tuple is not mutable. It is immutable. And that's one thing that differentiates a tuple from dictionary and lists. Now, tuples, dictionaries, lists, all of them have something in common, and that is items are ordered. Lists also allow duplication of elements. Not only lists, set data type has a characteristics with tuple in the sense that sets are also immutable. However, set elements are unordered. The set will rearrange it for you. And there is another characteristic. Set elements must be unique. Now, both sets, dictionaries, tuples, lists, all of them all together, they accept different data types. Now, dictionaries must have unique keys. The keys must be unique, but the values that you create there may not necessarily be unique. For instance, surname must be unique, but any person can put any name there that is a surname. Another person puts John, the other person puts John, is okay, but the keys must be unique. Tuple allows duplication of elements, just like lists also. That's something a tuple has in common with a list. So let's take a look at the diagram again and see at a glance the relationship between them. The only data type that I have not put here is arrays. However, we can see the similarities and differences between the four other data types. I hope this helps. So we have come to the end of the class today, and the bibliography remains basically the book of Eric Mathis together with the other ones that are listed. We also have a link that will make you learn more about Python arrays if you want to, and the NumPy Users Guide where you can learn more about NumPy if you are interested in that. So, like, share, comment, and subscribe for more videos. Thank you very much, and see you in the next class.